Okay, so
Okay.
so far we've been here, but Matthew and Susan have yet to join the group. Hopefully they will soon. And now we're gonna go over what you were saying.
So this next one I was looking at, and I'm a little confused on it. On just like, so we're replacing the variables and all that with the we're replacing x with f of x, function of x, and then you subtract the function at the end after you've put it through once, and then you divide by h.
With the difference quotient, you mean? Is that what you're talking about?
Yeah.
Okay, cool. Yeah, yeah, these ones.
I was just a little confused on this one. Do you put this in the, do you square that f of x, then times it, then add it to h, or how do you go around with that?
Oh, I see. I think you square the x plus h in there. We were given the equation x squared minus 3. So I think we'll plug in x plus h where the x is, and so we'll square the whole x plus h. Then we'll do the minus 3. Then we'll subtract the whole x squared minus 3 again. Does that make sense?
Okay. Yeah,
so go ahead.
So we'll write, let's see, x plus h squared minus 3, kind of like that. Let's see.
Yep, yeah.
All right.
And
that's
then we
what
subtract
I was trying to figure out how that all worked in there.
Yeah, it's weird. I always get thrown off a little bit by it.
This is where I usually get my problem wrong, is doing the foiling. I was like, we learned this in like what grade? Like 3rd, and I still can't do it right?
Right, yeah, it's like I still struggle with this.
Well, especially after going on your mission, you like don't use this for 2 years and stuff.
Yeah.
And you're like, what the crap even is this again?
Yeah, then you come back, okay, now you guys need to know this. You learned this already, so
like last week I was relearning how to do slope formula.
Oh man.
It's like
I should know how to do this.
I was like, I know how to do this. I used to be really good at this.
Yeah.
I just needed a refresher.
Right, yeah. But it's scary. It's like, holy cow. It's like, I have to learn this again? What?
Again? What do you mean again?
I watched your video, but I don't remember. Did you say you just got back from your mission? It was not too long.
Let's see. I got back in August.
Okay. Yeah, so pretty recently.
August, September.
Half a year?
I was only out for about a year because I had to come home once in the middle for an ACL surgery.
Oh, yeah, that's right. Yeah, you tore it, yeah.
And then I re-tore it and had to come home, and now I'm home for good, and I had another ACL surgery in August.
Oh, how'd you injure it again?
I don't know. So I've actually torn it 3 times.
Oh my gosh.
The first time was before my mission, and I had surgery. But that time is the only time we actually know what happened.
Oh man. Dang.
So I taught parkour.
Yeah, I saw you're a coach, right?
Yeah. And now you think I did something really crazy and cool, but no, I rolled over a box and stood up on my ankle sideways, and it put sideways pressure on my knee and tore my ACL.
Ouch. Oh man. Oh.
So no really cool story, just kind of a pathetic one.
That's all right. You can just say, I was doing parkour and I tore it, and people are like, whoa.
That's what I usually say.
Yeah.
And then they're like, what were you doing? I'm like, crap.
Crap, dig it. Oh, just high intensity somersaults over obstacles.
Well, then I continued to say what happened next is I had told my students that if they caught me going through this obstacle course, I'd do 100 push-ups.
Oh no!
And I still finished the entire obstacle course beating them. and finishing with a flip.
Oh my gosh. Okay, see, that makes it way cooler.
Right after tearing it.
Oh man. Ouch.
I still had like a 14-second lap.
Dang.
My record was 7 though.
Dang. So you doubled your record, but you were still way faster than everyone else.
Yeah. Luckily, I was teaching the younger kids that day.
Oh well, you can leave that detail out.
Yeah. Well, some of them are actually really fast. Some of them got up into 9 seconds.
Oh wow. Okay.
I'd really push my kids on their speed through obstacle courses.
Mm-hmm.
So one of the tricks is not to think too far ahead, but to think more in the moment. Because when you start thinking steps ahead, like you have it planned out, but then you aren't thinking about what you're doing next.
Oh.
And so you get kind of confused, and that's when you mess up your run and stuff.
I see.
So it's literally split-second decisions.
Yeah. If you're wasting time thinking ahead, then you're gonna miss out on those.
Yeah. Last night I was doing one of the homework assignments on this, and I was like, I have a 12xh, and over here I have a 6h and a 6x. I wonder if I just can subtract the 6's from the 12. No.
Oh.
Doesn't work.
No.
No. I was like, when you add them together, I mean, they're the same value, same amount of each. I was like,
yeah, but
in theory that should work, but it doesn't.
That doesn't quite work.
Another thing in math that doesn't logically make sense.
Yeah. I feel like the higher up you get in math, the more you realize how much you've been lied to.
Exactly.
Like, oh, actually, you can multiply by number. You can multiply it by number 1 if it's like the one number divided by itself. You can multiply the whole equation because you're actually multiplying by 1, or you can actually, turns out, divide by 0 in some cases, or just all these random things like that.
Or, oh, here, let's make an imaginary solution.
Yeah, here's imaginary numbers now, yeah. Yep.
Oh, you put an I at the end of it, and it's an imaginary number now.
Yeah.
It's not a real number, it's an imaginary number. What the crap? I was like, who comes up with this?
Yeah.
Like,
some people who are a lot smarter than me.
In what case did someone say, I need an imaginary number in order to solve my real problems?
Yeah, right? That's a great question. I'll have to put that in the discussion board next time.
We'll be like to the teachers, so explain this to us. We had this very insightful question that you can ponder on throughout the week.
Nice.
Insightful for us, not you.
Yeah.
Because you already probably know the answer.
Hopefully.
I'd hope so. Okay, now I minus f of x. Okay, I did substitute that and I had check. Squared minus 3. Okay, let's see if I got that right. Yes! I did it right! All right. Nice. Have you got the answer for that one?
2x plus h?
Yeah.
Nice. Sweet. I wish the answer key was a little more. I wish I had step-by-step answers sometimes. Like,
that'd be nice.
Thankfully, for this one, we didn't need this.
With some of these equations, have you ever used Wolfram Alpha?
Wolfram Alpha? I never heard of it.
It's a website. You can type in equations to it, and it'll give you step-by-step answers if you ask for it.
Nice. Okay, sweet.
So
that'd be really helpful.
I use that sometimes to help me figure out how to find answers.
Yeah. My math lab isn't always the best at that.
No. Like, on one of the homework, I was like, what the crap? Where did they get a 5? There's only a 2 and a 2.
Yeah, it's like, well, there's obviously some step here that you're assuming I know how to do, and you just jumped it, and I don't know how to do it.
Yeah, I was like, what is going on?
Yeah. And this next one's kind of a beast.
This one's going to be a little bit bigger.
Yeah, just a little bit.
Just a wee bit.
Yeah.
And a bit more annoying.
Yeah, it's like
now I have to figure out how to put it in that equation.
Yeah. So yeah, that's the hard part, figuring out how to put in the equation, and then just like the algebra itself isn't too difficult, but it's just like there's so many places you can mess up at.
Because like I don't want to put more than 2 numbers in the inside the parentheses squared.
Oh yeah.
But I feel like I'm gonna have to.
You think so?
But I'm not sure. Okay. I don't want to. I'm gonna just not put 2 numbers in there squared and see how it goes. One of those days. All right.
Oh, Susan just now responded that she can't make it to the meeting.
All right. I think we have to have another one on Thursday.
Yeah. Yep, Thursday. What time would be good for like? What time would be good for you guys for you on Thursday?
Nothing too late because I'm leaving for Rexburg around like 5, so I have to get ready for that. So probably just sometime before 2.
Cool. Yeah, I'm mostly free in the morning aside from my one class. So like, we could do it as early as 6 a.m. if you wanted to, if you really wanted to.
I don't know if I want to quite get up that early.
Yeah. I'll ask you in the group what time people want.
Call me crazy. Mainly because I don't have to get up that early right now, but
yeah.
I mean, if that's the only time that works for everyone, I will, but
hopefully we can work something out. It's not quite that early.
We'd all be kind of like zombie-ish for the questions.
Mm-hmm.
And so is this assignment for the next meeting as well, or do we have a different one, or what are we doing during
the next one? Next meeting? Not sure. I think the next one is for lessons 3 and 4, because this week we're covering, or this meeting we're covering 1 and 2. And then on Thursday it will be for 3 and 4.
Okay. So far, I think I am doing good. Except for one part. Oh, wait, no. Actually, no, I'm doing good.
Nice.
It will even out. Kind of.
Kind of.
How does that become a -3 from a +4?
Susan wants to do a meeting at 9:30 again.
Okay.
I'm just thinking that might be pushed because I'm guessing these are normally going to take at least an hour. Because I had to leave early today, and we got like through about half of it. Right?
Yeah. And I think the next time we have to do a quiz or something.
Oh yeah, there's a group quiz as well.
We could do 9.
Yeah, I think 9 would be better. I'll tell that to her.
Okay.
What part are you at now?
Trying to figure out what happened to my equation. Because I feel like I went wrong somewhere and broke it. Oh, I forgot to bring stuff down.
Okay. That's nice when it's a mistake like that. It's like, oh, that's it. Phew.
Other than the fact I'm still missing -3.
-3.
It's supposed to come from somewhere, but I don't know where that comes from.
Did you get, let's see, there's a -3h in my equation that the h gets canceled out and leaves me a -3.
What?
Yeah. So when you plugged in your, go ahead, sorry.
Here, say what you're gonna say.
When you plugged in your stuff to the equation, did you plug in x plus h twice into both x's?
Oh, I didn't do it to both x's.
Okay. I think that might be where it. That might, because that's where you get your 3h.
Okay, so then I get my -3 from there. Then I factor out h. Leaves you with 4x plus 2h minus 3. There we go. There's the answer we were looking for.
Nice. -3.
4x plus 2h minus 3.
Awesome. That one was definitely A lot of stuff to write down on that one.
Yeah. A lot of places you can go wrong on that one.
Yeah. Yeah, for real. Okay.
A lot of places I did go wrong on that one. All right, 2 left.
So now that you have learned the parent function for many different functions, you can now graph piecewise functions. Oh, really? Okay. Piecewise function is a function that's graphed using pieces of other functions. Okay. So x plus 2 and x is 2. Okay, well, looking at parent graphs, I recognize an x squared, and an x squared is like, it's like a parabola, right? Right?
Not according to their. I'm looking at their graph that they have graphed for the answers, and I do not understand it.
Looking at them, I'm like, what the heck?
There is no. I mean, like that 2, the one that the red line. That one could be a parabola if it went the other way too.
It was upside. Yeah. Huh. And like,
but since it's a function, it wouldn't have passed. If it was a parabola like that on its side, it wouldn't pass the vertical line test. So
true. This one, that middle line there, it looks almost like the radical parent graph, but there's not any radicals in this one.
Maybe they put a radical to get rid of the x squared.
Oh, maybe. Well, yeah, maybe. But there's also a graph with, yeah, maybe right. Huh. I don't understand how to do that though.
I don't either.
And I honestly didn't see anything. Like I got the first homework assignment done, and I didn't see anything with these in the entire one.
Good. Huh. I don't have to worry about those till the next assignment then.
Let's see. So what would we do? What's the following piecewise functions? Okay, I'm going to do a little Google search real quick.
Okay. Let's see. Hey, there's a radical in the next one.
You what?
There's a radical in the next one.
Oh, is there? What does that one look like? Yeah. Oh, wait. They almost look like
very much smaller graph. Hand drawn, it looks like.
Yeah, hand drawn, it looks like, yeah.
I believe that is a, what would you say, an 80-degree angle on one side, and that the y-axis is 80 degrees off. I mean, 10 degrees off of 90.
Maybe. It's a little bit. Yeah, just a little bit. It almost looks like the same graph, except mushed together a little bit more as like the previous one.
Well, and the other thing I noticed is that line, the curved radical line that we're going to call it, is above the start dot for the straight line.
And I noticed some of these are like, they have open circles and closed.
I was just about to say that.
Yeah.
Maybe it's like when you use a number line with a with the greater than or equal to. Maybe those mean greater than or equal to, and the closed dots are just greater than.
I bet you're right, because in the first one, we have a greater than or equal, less than 2 sign, and then we also have a greater than or equal to sign.
Yeah.
But, we still have 2 open circles and 2. I don't know. I think you're right.
I don't understand exactly how we get 3 lines with 2 equations in that first one.
Yeah.
Where in the second one has 3 equations and we still only get 3 lines.
Yeah. Oh, that's true.
So, how do you know how many lines you're supposed to have?
I'm not sure. That's yeah, that's a good point because we have 2. Okay, well, let's see. Greater than, okay, well, it's okay if x is less than -2, and it's x plus, okay, maybe, well, like if I'm looking at the yellow one on the first graph, it goes down. If it's less than 2, it's, well, but it's less than negative. I don't know. Not sure how to interpret
Do we want to try to get these parent functions into y equals mx plus b? Is that what we're supposed to do, or how are we supposed to graph these?
Yeah, I'm really not sure. There's a Khan Academy video. Well, I'm gonna see if I can find a video that.
All right.
10 minutes long, but like, okay, here's one that's 5 minutes. Maybe that'll be enough. Yeah, hopefully I don't have to watch the whole thing. It loads. Okay, this one's 3 minutes.
Okay, where did I get a? Oh, I was writing the problem down and you said 3, and I was like, wait, where did I get a 3x?
Oh.
Okay, x.
All right, let's go.
Okay, now this is another interesting thing I just noticed when I was trying to write down this problem. If you look at the way the problem in the first one's written, it says x plus 2. Then there's a space, x is less than -2.
Yeah.
So are we supposed to multiply there, or is that 2 separate equations?
I think they're 2 separate things. But then, oh, okay, maybe. Okay, so if you look at like where it says x squared space x is less than or equal to -2.
Yeah.
Maybe there. Okay, so x squared, that looks like a parabola. And if you flip the yellow line, like if you give the yellow line another side,
yeah,
it could look like a parabola flipped upside down. But since it's less than or equal to -2, or greater than or equal to -2, like maybe because -2, you know how if it's negative, it like the or maybe that's the y.
Because it's greater than or equal to -2 instead of just being equal to, it doesn't go both ways, or
maybe. I'm thinking maybe since that 2 is negative, it flips, but then there's also -2 above, and that's not flipped. So, man, this video does not want to play.
This is really confusing.
Wish Matthew or Susan were here. They might know more than we do. Okay, Susan can do 9 o'clock, she says. Matthew hasn't responded yet.
All right. That sounds good.
Well, maybe I haven't had much luck with the book, honestly. It's just a pain.
It's kind of confusing.
Yeah. This is the video for piecewise functions.
That's not piecewise. That's pennywise. Does that mean if they were good with money? Whoa, wait. I'm talking about piecewise defined functions. Let's get your mind on math, people. Yeah. Function. It's a function. It has several different.
Bear with me.
Okay. On and off switches over here. This. Are we in a club? No. Okay. This tells us which piece we're going to use when...
I feel like this is a way funnier video when you can't see what's happening on the screen.
Yeah.
I wanna evaluate.
Because all I'm hearing is all the talking, and it's hilarious.
Okay. That's gonna tell me which piece I'm in. Am I here? No. Why? Because these are the ones that are less than 2. Am I here? No. These are the ones that are in between -2 and 2. I am here. Why? Because my x's are bigger than 3. That means use this one. And then here we go. So what's my x gonna be? It's gonna be 3. So minus.
Maybe we plug in that.
3 plus.
I don't know how you'd write it, but so the x
it's 1.
equals a number greater than less than -2.
Sorry, say that again.
So like in the equation where it's telling us has the space between the two, maybe it's saying that x is. So it's saying that x is less than -2, and then maybe replace x with something saying that.
Yeah. Yeah. So like we could put, in this case, less would be like a -3, right? Because as you go.
Maybe you just test it.
Yeah. Okay. Well, so that would give us what? -3 plus 2 would be -1.
Which is. Well, if we just had 1, that's where that start point is for that yellow line. But also, I don't know which of these functions is graphing which line on this graph.
Yeah, that's true.
And I think we're only supposed to be finding domain and range. At least that's what the answers show up as.
Yeah, it says, but to find the domain and range, don't we have to, like, because we'd have to see what this is doing, wouldn't we? So, like, we have to see both ends, so we'd have to graph it, wouldn't we?
Not necessarily. In the homework assignment, you figure out the domain and range a few times without using a graph.
Oh, that's right, we did, huh? Okay.
But I don't think we ever did from a parent function. We were just doing normal functions, I think.
Yeah, you're right. I don't think we did anything with parent. I don't remember doing anything with parent graphs so far, anyway. But
this
guy's doing something weird.
Things.
This guy's doing something interesting though. He's like, I don't think he's the right video for this one. I'm gonna try. As fun as this guy is to listen to, I'm gonna try this guy. Here we go. I bet it's something really simple once we understand it, and then we'll be able to blow through these.
Oh yeah, it usually is. Well, at least we heard from Susan.
Yeah, we heard from Matthew earlier, but then he just kind of disappeared again.
Maybe he had class.
Maybe. Is her number?
A really long class.
Oh, really? Yeah. It's funny because the number that Susan provided in like the sign up chart thing is different than the number she texted on.
Yeah, I saw that because it opened a new group chat.
Yeah, it's like it's not like just one digit different. It's like a completely different number. So. Okay, here we go.
Maybe she had like a home phone number and she gave the wrong one.
Maybe.
Is they want us to graph the function g of x of -2 when they want us to graph the function g of x equals x minus 3 when x between -1 and 5. And they want me to graph the function g of x minus 15 only when x is greater than 7. Now, start g of x because actually g of x is all of them combined, but I had to use the function, so I used g of x. The function of all three of these combined. They're all individual functions that we need to graph. So what I'm going to do is I'm going to have to graph each one of these separately according to their constraints.
This guy's doing a good explaining good.
Remember.
All right. So is it making sense?
So far, yeah.
All right.
Graph XY plane. It doesn't matter what your x value is. Y is always going to equal. Y is always going to equal -2. So it doesn't matter what x value I pick. Y always equals a -2. So really, that graph is going to look. It's going to be a horizontal line at -2. Then the next thing I need to look at it is that says this graph is only true when my values of x are less than -4. So I go to -4, 1, 2, 3, 4. So that means this graph is only true from this point. Since it's an open circle, that's going to be an open dot. Right? Because it does not include the point -4. So the rest of this, even though I wrote it down a line, it really has no effect. It's not part of my graph, or not part of my function g of x, my piecewise graph. X minus 3, I need to graph that. So that crosses at a y-intercept of -3 and has a slope of 1/1. So that looks something like that. Now, that graph is only true between -1 and since it's now less than or equal to that.
Wait a second. Okay. That is
true between negative. So that looks something like that.
Wait. Almost there.
Got that. So that crosses at a y-intercept of -3 and has a slope of 1/1. So that looks something like that. Now, that graph is only true, but since it's now less than or equal to, that's going to be a solid dot. Less than or equal to 1, 2.
X is less than -2. Okay, so I think I've got it. So like basically what this guy's explaining is that the graph is saying the following. So we can separate that into kind of two equations. We can write f of x is equal to x plus 2, and then we write the word when x is less than -2. And then what we'll do, f of x is another way of saying y. So we're saying y equals x plus 2, but we're going to go to a plus 2 on the graph. And then that's going to have a slope of 1/1 because we got y equals x plus 2, which is like you were earlier when you were saying that's in slope-intercept form. So our slope is 1/1. So then we got a up and over 1, up and over 1 both ways, and then down and over 1 both ways. So we should get a line, a straight line going up to the right and down to the left from +2. Like upwards on the y-axis.
Okay.
But then we have to take into account that that's only true when x is less than -2. So if we go to where x is less than -2, that could be -2.1. So it'd only be true after that point. But I'm not seeing that on any of.
So now this graph is only true, so this function is only true between these 2 points.
Yeah, like you were saying too, when it's like just less than or greater than, that's an open circle. When it's less than or equal to or greater than or equal to, then that's a closed circle.
All right. At least we figured that out. Now we just have to figure out how they got a domain and range of -∞, +∞, and -∞, +∞.
like looking at this graph, I can see because we've got the two like the lines aren't all connected, but we've got the two end behaviors of the blue and yellow. And
yeah.
we can see that right there is
that those two go on forever.
Yeah, exactly. Let me watch these.
The first one goes on infinity in one direction, in the negative direction, and the other one goes in the positive direction infinitely.
Yeah. Mm-hmm. As in the yellow one, as x goes to infinity, y also goes to or as x goes to negative infinity, y goes to negative infinity. On the blue one, as x goes to infinity, y also goes to infinity.
Yeah.
Yeah, so that makes sense. So yeah, okay. I'm gonna watch him one more time because I feel like I missed something.
That's a open circle. That's going to be a dot, right? Because it does not include the point -4. So the rest of this, even though I wrote it down a line, it really has no effect. It's not part of my graph, or not part of my function to that's my piecewise graph. The next one, x -3. We graph that. Well, that functions at a y-intercept of -3, and it has a slope of 1/1. That looks like that. Now, that graph is only true between -1 and less than 3.
I'm going to send you this video because I think you're doing a good job of explaining it. I'm just not very good at understanding it, maybe. So if you want to watch it, go for it. If not, that's okay too. But maybe you can make more sense of it than I can.
All right.
I think I just don't understand what's making their graph in the answer sheet. Why is it curved like that? I'm going to try it. And how do we get 3? How do we get 3 lines? Ugh. This is confusing.
Very. Very confusing.
This might be one of the rare cases where my math lab is more helpful. It's like when we get to in the homework, you just learn how to do it in the homework and not in class, you know?
Yeah.
Maybe, but. Oh, is that yellow line supposed to be a straight or curved line?
It looks curved on the graph.
Mm-hmm.
Because it doesn't have the same slope, and you can see a slight curve in it.
Yeah.
I think. Unless that's just my monitor.
I think it's curved too, but okay.
It's hard to tell sometimes. I have a curved monitor, so some lines they're supposed to be straight look curved.
Oh, okay. Yeah, well, this one looks curved to me as well. So.
All right. I mean, it's not a very big curve, but it's just barely there. Its radius is probably like 100 grid away from there. I mean, it's a center point.
Sorry, what was that?
The center point of that arc would probably be like 100 grid to the right bottom corner.
Oh. This one right here. I did. Ugh, yeah, I really don't follow this.
Let's see.
Well, I mean, we've spent like altogether an hour and almost a half here. So
yeah,
if you're good calling it quits and just trying to come up with it on our own, and we can text each other if we figure it out or whatever if we have questions.
All right. Yeah, that sounds good.
Okay. Sorry we couldn't figure this last bit out, but hopefully we will go in the homework.
Yeah.
I mean, sorry, go ahead.
We can touch on these last two with the group on Thursday.
Yeah, good idea. I'm starting the homework I'm working on the number 2 homework today. So if I get to it, I'll text you when I figure it out.
All right. I'm finishing up the number 1 and then I'll go to number 2 today.
Yeah, it's like, holy cow, 30 problems in homework. And then since it's math lab, it takes a little bit longer because if you get like one sign off or an extra decimal or something, it takes that much longer.
Yeah.
All right.
But all right. Talk to you later.
Talk to you later. See ya.
Okay,
Stop.
bye.